Today's topic is properties of vector space. Properties are coming from let theorem, that let V over F be a vector space over a field F and 0 V the 0 or null vector. Okay. We are representing this 0 vector like that over bar. Created the basic difference between basic difference between 0 and 0 vector or null vector. The first property states that a into 0 vector, that against the 0 vector, or we can say that the 0 for all a belongs to field. Second one is 0 to alpha, so null vector into alpha equals again a null vector for all alpha belongs to field F. Next one is a of minus of alpha equals to minus of a alpha for all a belongs to F and minus alpha belongs to V. Next one, fourth one is minus of a alpha equals to minus of a alpha for all minus a belongs to F and alpha belongs to V. Next one is a of alpha minus beta, which is equals to a alpha minus a beta for all a belongs to F and alpha beta belongs to A. Sixth one is if a alpha equals to 0 vector, which means if a equals to 0 vector or alpha equals to 0 vector. Next one is a of alpha. Here is also the a belongs to F and alpha belongs to A. A alpha equals to A beta when alpha equals to beta for all A belongs to F and alpha and beta belongs to A. Next one is A of alpha plus B of alpha, which means A equals to B for all AB belongs to field and alpha belongs to B. ये सारी इस प्रॉपर्टी होती हैं वेक्टर स्पेस की. तो फर्स्टली भी स्टार्ट करेंगे प्रूव यहाँ से, इन दोनों को प्रूव करेंगे, फिर इन दोनों की मदद से इन दोनों को प्रूव करेंगे प्रूव के टाइम, फिर इन चारों की मदद से इनको प्रूव करेंगे और फिर इनके बाद इन सारों की मदद से इनको प्रूव करेंगे. ये पूरा ओवरव्यू है कैसे अपन प्रूव करेंगे. लेट गो फॉर first one property, which means a into 0 vector equals to 0 vector. Proof. Zero vector ka simply means like a zero or nothing more like that. Put in the mind that 0 is like zero vector is like a zero value, but it is not a same, but we assume that it is a zero. Like if we take from the left hand side, it's a of zero vector, we can write it like that: a of zero vector plus zero vector, because we know that the addition of two zeros, zero vector equals to 0 plus 0, or so on. How many times we can take? There we need only two, so we take this two. Step forward, step forward. A of 0 from a vector 0, a 0 vector, a 0 vector. By properties, properties of vector space. It's a part of pure mathematics to we write the detail about what is the step we taking there. We can take like that: 0 vector plus a 0 vector, a 0 vector plus a 0 vector. And adding the 0 vector or 0 in any digit, there is no changes in their value. So we can then e 0 vector plus a 0 vector is again a 0 vector. Okay, that's all. Now what, by cancellation, by right cancellation law, we get like that: equals to a of 0 vector y right cancellation law. Cancellation law, which means right hand side, so we cancel this right one values like that. They are not actually cancelled, but the law state like that. So we starting from a 0 vector equals to 0 vector, and we comes to prove that it's a 0 vector equals to a 0 vector. Second one, 0 alpha, 0 vector alpha equals to 0 vector. Step forward, we can 0 vector equals to 0 vector plus 0 vector to alpha to 0. Step forward, 0 vector alpha plus 0 vector alpha equals to 0 vector. Now this is 0 vector alpha plus 0 vector alpha equals to again 0 vector 0 alpha 0 alpha. We take from the same, this we take and we going to from there, and we now we say that this second one, this step is 0 vector, and what cancellation law, this 0 vector equals to 0 of alpha. Same as the previous one, we taking from that, like 0 vector alpha equals to 0 vector. Here we shown that this 0 vector we can write like that: 0 vector equals to 0 plus 0. We put it there. By the properties of the vector space, we can then say that 0 alpha plus 0 alpha equals to 0 of alpha. And if we add something from also take the 0, or we can 0 means nothing to add, but the method pure mathematics is something else. It has some value. 0 plus 0 alpha, 0 vector plus 0 0 vector, a 0 vector equals to a 0 vector. And while there we got this, and while the right cancellation law, we got this conclusion. We can, the third one is 0 of a of minus alpha equals to minus of a alpha. Yes, minus of a of alpha. Proof. For proof, we taking our proof like that, that is alpha 1 0 alpha equals to a 0. We know how we take from the side, take a 0 or this. So the concept is that the inner value is this negative 1. If we assume that this minus, so this outer one is we have two properties like this a 0 vector equals to 0 vector, or second one is alpha 0 vector equals to 0 vector. Here we need this a1 a, so we use this property. So now we come this, we write a 0 vector equals to 0 vector. Again we step forward, we can write it that a of alpha plus minus of alpha equals to 0 vector. Okay, alpha plus minus of alpha equals to 0, and for all a belongs to f and alpha belongs to this b. Okay, that's all. Now going step forward, next step, by the property of vector space we insert this a and minus of alpha equals to 0 vector. By properties of by properties of vector space, property of vector space. As we seen there is this whole value, and this whole value comes in the addition and gives the 0 vector, which means they are opposite to each other. So we can write like that, this a of minus alpha equals to minus of whole of a alpha, because this when we add both of them, or when we operate doing operation between both of them values, so they will be the 0 vector. Or we can take a like simple example like that, not taking too much hyper, like that. Okay, we have this 2 plus of minus of 2 equals to 0. So what is the meaning of this? This 2 or this minus 2 are opposite to each other, or the inverse of each other. So we are writing this, there is an addition operation, so we use a minus 1, as we know. Okay, now this we proved it. This theorem is like that. So, or we can first we prove that this a 0 vector equals to 0 vector. Second, we prove that this alpha into 0 vector equals to 0 vectors. Now we prove that a of minus alpha equals to minus of a alpha. And now we go going from this, alpha minus a alpha equals to minus of a alpha. Okay, now we go like that, minus a alpha equals to minus of a alpha. By proof we use the above proof, like that, alpha into 0 vector against give us 0 vector. And we going to step forward, we can write that is 0 is a of minus of a, because it is a 0 vector. A of minus of a against give us 0 vector. Now by the properties of vector space we can multiply inside of them, and then we got alpha minus of a equals to 0 and 0 vector. From this, so the properties of by properties of vector space, property of vector space, and as you know that the above proof, this whole values are opposite to each other, or the inverse of each other. So we can write like that, minus a of alpha equals to minus of a alpha. That's all. We are proving this 4, and the next 4 are being proved in the next session.